Okay, now for what we have in the fourth problem, okay, we have only the square of the sine of 17x dx, and to be able to integrate, okay, and since we have only an even power in one trig function, okay, what we can do is that we can now, instead of applying the main Pythagorean identity, we can revert to the double angle formula. Okay, so for sine square of x, this will be 1/2 minus 1/2 of the cosine of 2x. But now with x equal to 17x, this signals that x, while it is 17x, is going to register that 2x will be at 34x. So in the rewrite, okay, we now have the integral of 1/2 minus 1/2 of the cosine of 34x dx. And as we look at the follow through on this one, okay, we have splitting it up as two integral statements. We have 1/2 times the integral of dx minus 1/2 of the integral of the cosine of 34x dx. And so for what we have in the setup, we now have 1/2 of x minus 1/2 of what is going to be 1/34 of the sine of 34x followed by the constant. And so we have, for the complete answer, final answer, we have 1/2 of x minus 1/68 of the sine of 34x followed by the constant. Okay, now for what we have in the fifth and remaining problem, we're looking at taking the integral of the fourth order of the sine of 2 theta d theta, and since we have only an even power to which we have one trig function raised, we are looking at the repetitious use of the double angle formula. And now for breaking up what we have here, the fourth order of the sine of 2 theta, okay, that's going to be the sine square of 2 theta times itself d theta, and converting what we have in terms of the double angle formulas, okay, for sine square of 2 theta, okay, that is going to be at 1/2 minus 1/2 of the cosine, and this time the angle is going to double to 4 theta. And again, we do this, and we're going to FOIL out the terms. And so for what we have in this arrangement, okay, we have 1/2 of a half is going to be at 1/4. Okay, we have minus 1/4 cosine of 4 theta minus 1/4 cosine of 4 theta. So we have minus 1/2 of the cosine of 4 theta, and this will be plus 1/4 of the square of the cosine of 4 theta d theta. And so we will be breaking up with the double angle identity. Once again, we have cosine square of 4 theta, and so upon looking at branching this out even further, we have 1/4 minus 1/2 of the cosine of 4 theta, and then we're going to have plus 1/4 of 1/2, which in this case will be at 1/8, and then we have plus 1/4 of 1/2 is going to be 1/8 of the cosine of the double angle, and this time the double angle we will have at 8 theta. Okay, and so we have like terms with the constants 1/4 and 1/8. Okay, so this will lead up to 3/8 minus 1/2 of the cosine of 4 theta. Again, we have plus 1/8 of the cosine of 8 theta. And so working with what we have, taking the antiderivatives, okay, we have 3/8 of theta. We have minus 1/2, and the antiderivative of cosine of 4 theta is going to be 1/4 of the sine of 4 theta. And then we have plus 1/8, and this will be where the antiderivative is going to be 1/8 of the sine of 8 theta. Followed by the constant. And so we will have for the final result, okay, this will be at 3/8 of theta minus 1/8 of the sine of 4 theta, and then we have plus 1/64 of the sine of 8 theta, followed by the constant, and thus that will be the final answer.